Hello everyone, welcome back to Mathematica. Hope you all had a great Friday off. Even though the football game kind of was not great, I still hope that didn't ruin your Friday. Okay, so this week we're going to go over CS style scripting. So far we've only done kind of like do this command, then do that command, and do that command, just a chain of commands to run in Mathematica. This will show you how to make them a little more more zesty. Yeah, wrong choice of word, but I'm going to go with it. Yeah, we're going to make your code look more zesty. So yes, this is very common in programming languages if you've never used a programming language before. They're super useful and they're great to work with. So yeah, let's jump into that. Okay, so the first thing we're going to look at is the if statement. So the if command will take in a testing cause here, and if it's true, it'll print out this. If it's false, it'll print out that, as you can see here. 2 plus 2 is 4. So it'll print out this. A cool thing is that the if command has a condition if none of them is true or false. So basically, if it returns a non-true or false value. So let's see what happens when we do 2 plus 2 for that case. Oh, look at that! It prints out Devin is great, which he is. So yes, it'll give a U condition if the testing condition here is neither true or false. Pretty cool, huh? Alright, so more examples here. Blah, blah. Oh, also within a if statement, if you want to have multiple commands execute, you just separate them with a semicolon, which is pretty cool. Alright, so the which statement is basically the mathematical equivalent of a if-else ladder. For those people that have never coded before, an if-else ladder is basically just, it's pretty much what it says. It's a ladder with if statements. Let me just draw that real fast on my high-tech visualization software here. So we have an if, and then we check the condition. If it's true, then execute that, and if there's else, if just check that, execute that if it's true, blah 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 blah, and then eventually we have the else. I spelled else wrong. Okay, else, and then it'll run whatever's left. Okay, so this is for just checking the value. That's pretty much all it's used for in CS. But so yes, this which statement essentially does the same thing, right? It'll take in, let's get that. It'll take in a test and it'll see if it's true. If it's true, it'll do that. If it's true, it'll do that. It'll just keep going. And so yes, so as we can see, 6 is not prime, so it does not print this. 6 is not negative, so it does not print this. 6 is indeed even, so it will print this. Okay. Okay, so which also has a third argument. Let me format this to be a little easier. Come on. Returns no. So yeah, none of the things were satisfied, so nothing will get printed out. Yeah, that's that's about it. Okay, the switch statement. This basically takes in a testing cause here. Oh, oops, what just happened? Okay. Takes an expression and it'll compare it to these form values, and if any of those form values are true, it'll print out, or it'll execute whatever the value is. So just to make this easier for the eye, this giant number modded by 5 is one of these 4 values, and so the switch statement will just go to the one that it is. So for example, this modded by 5 is apparently 1. Cool. Okay, so the next thing we're going to go to is the for statement. So the for statement is very useful for kind of just iterating through a set of numbers at a given interval. So syntax goes like this: we set a variable equal to initial value, and as long as that variable is less than some given value, then we increment that variable by this much. Let me just do that. And then inside the loop, we set j equal to I squared, and we print out j. Just so you can see the syntax. So yes, it takes the start, test, increment, and body. And let's say we want to increment by 2. we can just do plus equals 2, and it'll increment by 2. Okay, cool. One thing that you do need to worry about is that sometimes this weird thing happens where it'll print out null, and that's just the for loop being kooky. Yeah, it's kind of a jank output, but what we're trying to do here is we're trying to call the for loop on these given x values. So as you can see, x is defined here, and so it'll go through and it'll substitute this x with that, this x with this, and this x for that, and it'll print out these values. But to fix this, just simply put a semicolon and it will fix everything. Pretty cool, huh? Okay, the next thing we're going to go to is the while loop. So the while loop will take in two conditions. It'll take in a testing condition and then what to do if it is true. So basically the while loop will keep running as long as this statement here is true. So one thing to be very careful of is infinite loops. Infinite loops are loops that do not end because your testing cause is wrong, or you're just kind of just sleep deprived and you can't focus. So let me show you an example of what an infinite loop would look like. So as I said earlier, the while loop will keep running as long as this cause here is true. And since this is true and it will never not be true, it will keep running forever. So let's observe that. And there you go. You have an infinite loop. Congratulations. Lesson over. Now I have to burn my computer. No, I'm just kidding. Alright, so what do we do when we're stuck in Mathematica? We quit the kernel. Shabam, and we're safe. Just to make sure I don't mess this up later. Okay. Okay, last thing I'm going to talk about. It's kind of a big topic, very useful. Block and module. So as I've already mentioned earlier in last lessons, every variable in Mathematica is global unless it's in a block and module. And now what I mean by that is if we define x to somewhere over here, we can actually access that and use it down here. Okay, unless of course like we redefine it or whatever. Warning: variables across notebooks are shared. So if I have x defined in one notebook, I can access that value from another notebook. We've mentioned that at the beginning of this class, but like, yeah, we forget sometimes. I was doing my final project for this class when I took it, and I had two notebooks open, and I couldn't figure out why my code was working. And then until like 5 a.m. in the morning, I realized, I was like, oh no, I have x defined in this notebook. Anyways, so as dumb and naive as I was back then, I should have been using block and module because these are the only ways to actually make sure your variables are what they are. Unless you're like careful, which I'm not at all. So we have block and module to take care of that. Okay. Anyways, let me just show you what this does. So basically, we have x defined as 5 here, and so what module will do is it'll redefine x in a local scale. So it says, okay, any global variables that are called x, forget them. Okay, this is my x. Nobody else's x. This is mine. And so as you can see here, we manipulate x to be 7 here, and this will print out 7. So the module block here prints out 7, and the x value here prints out 5. And this did not touch this 5, or sorry, this module block did not touch the global x, which is here, because module defined this x inside here to be local. Okay. Another cool thing we can do with module is we can define a variable inside here, inside the list here. So as you can see, we set x to be 7, and then it'll print out 49, and x is still remain untouched from outside. Okay. Also, if you ever need to clear your variables for any reason, you can just do them here. You don't have to quit the kernel every time, although it may be very fun. It's basically the task manager of Mathematica, which is very useful to have. Oh, brownie points if you know what this is. Anyways. Okay. So yes, we clear the variables here. This is just an example of the difference between block and module. I know we didn't go into too depth with block, but like, it's not that different from module. It just obeys different rules. So we define y over here to be x squared, and module will set x to be 3. So then it'll print out a list of x and y. So it'll print out 3 and oh, wait, why does it print out? Oh, you know what? Would you look at that? Y defined here has a global x, whereas inside module we have a local x. Since we're calling y from the global sense, right? This has a global x, so it'll print out the global x. Not bad, right? Yeah, module's pretty nice. So yeah, one thing I failed to mention earlier is that module isn't totally blind to the global notebook. It can still access variables. It'll just treat them as like global variables. It'll basically separate the local ones from the variable ones from the global ones. And so yeah. Now let's take a look at block here. The same thing as above, except we call x and y, and this prints out 3 and 9. Now, block is a little different. Anything defined within here, it'll keep it local, but anything you call global, it'll just take it in and act basically. It'll just basically substitute it. All right. So as you can see, we call y, which is x squared, and it'll pass in rx into y. And I'll print out 3, 9. Okay. Also, one thing to note is that we can indeed change global variables inside block. So if we set y to be Devin is great. Heard that before. Oh, I forgot to print it out. Well, it prints out here anyways, but let's just mute that. Y here. Yes, it'll print out Devin is great here. Now let's say we wanted to preserve the value of y. Let's reset y to be x squared. Yes, y is preserved because we defined y to be a variable that we want to preserve inside block here. Or sorry, we want to define y to be a local variable inside block here. All right. And so yeah, that was today's lesson. About 12 minutes. Not bad, not bad. If you have any questions, please post on Piazza, because that's the best way for everyone to learn. If like people see other people's questions and kind of learn from that. Also, you're more guaranteed to get a faster answer on Piazza than if you email us. I mean, there's nothing wrong with emailing us, but we kind of want the whole class to benefit. Yes, I believe there is a homework due Monday. Project 1 is coming out very soon. I'm going to write that on my arm to do that tonight. Other than that, I guess we'll see you guys next Friday. All right, have a great weekend.